Hi everybody. Okay, so today we're going to be talking about systems of equations, but we're going to be using them in word problems. So to start off, let's talk about the three methods that we know already that we can use to solve a system of equations. Okay, so a system we can solve by either graphing, which we've talked about in class is very approximate, not the best method unless it's already in y equals mx plus b and you feel good about your graphing technique. We can use substitution, remembering that we want to use substitution when we have a coefficient that is 1, and then elimination, where we're adding the equations together and watching one of our variables get eliminated. All right, so why do we even do all this? We do this so that we can solve word problems. So for the next couple of days, we're going to solve all different types of word problems. But let's look at what we used to do. We looked at questions like this earlier in the year. John has 15 coins. They're all dimes and quarters, and they're worth $2.55. How many dimes and quarters does John have? Okay, so I taught you a one variable method. If we said we've got dimes and quarters, well, I said, okay, let's let D equals dimes. And if he has a total of 15 coins, in terms of D, how many quarters does he have? You guys would write 15 minus D would give me the amount of quarters he has. Then we'd write one equation in one variable, and it would have to deal with the value of the coins. So we would do 10 times D for dimes plus 25 times 15 minus D for my quarters equal the total of 255. Okay? That's what we used to do. Today what we're going to do is I'm going to show you how we use systems of equations and two variables to make this somewhat easier for ourselves. Okay, so here's how we would look at that same problem using a system of equations. All right, let me grab my copy so I can look at the question when I'm doing it. All right, so John has 15 coins, all dimes and quarters. So we're going to let D equal the number of dimes. And we're going to let Q equal the number of quarters. Uh-oh, my computer's doing something funny. Okay. All right, so now we have two variables, but remember when we write a system of equations, we're going to need two equations and the two variables. So now, how do we do this? Well, first we're going to relate the first question to the amount of coins he has. He has 15. So that means D plus Q equals 15. All right, and we're going to relate the other equation to the value of the coins. So 10D plus 25Q equals 255. Okay? Now, you have a choice of how you want to solve this problem. I actually prefer to use elimination. We've talked about this with these word problems if they're in standard form, just because it's a little bit neater, but it's going to be a choice. So I'm going to use elimination on this. I'm going to look at the D's, and I'm going to multiply this equation by a negative 10 so that the D's will be my equations that will get eliminated. So I'm going to multiply the top equation by negative 10, and I'm going to rewrite it neatly right under it. So I get negative 10D minus 10Q equals negative 150. Then I can add the equations together. The 10D minus 10D is going to get eliminated. 25Q minus 10Q is going to give me 15Q. And then 255 minus 150 is going to give me 105. Okay? Is that right? Yes. All right, then I'm going to divide by 15, and I'm going to get Q equals 7. So if I have a total of 15 coins, I take my 7, I plug it back in to find D. That means I'm going to have a total of 8 dimes. Voila. Okay? All right, well, let's look at some harder problems, or ones that might look a little bit different to you. Okay, so the first thing that we need to know about a system of equations is that since a system has two equations with two distinct variables in most cases, then a word problem will have to have two variables. That means look for the two unknowns. You have to look for the two unknowns. All right, so let's look at our next example. Anne and Betty Together, Ann and Betty have $60. Ann has 9 more than twice Betty's amount. 9 more than twice Betty. How much money does each have? Well, hopefully you're seeing that the two unknowns are how much Ann has and how much Betty has. So we're going to let A equal the amount Ann has. And we're going to let B equal the amount Betty has. Okay. All right, so let's write our first equation. Our first equation is going to relate to how much they have together. Together means add. So Ann and Betty, so A plus B, they have $60. Okay? A plus B, they have $60. All right, so then I've got to deal with the other part of the equation. Ann has, remember has is like is, so Ann has 9 more than twice Betty's amount. So twice Betty's amount is multiplication, 9 more is addition. All right. Now looking at this equation, I have a variable solved for, A is solved for, so substitution's a better method. All right, so I'm going to take 2B plus 9 and I'm going to plug it in for A. So we get 2B plus 9 plus B equals 60. Remember when you rewrite your equation to be really careful, okay? All right, so then I get 3B, oops, changing colors. Away from green. 3B equals 51. So I brought the 9 over. And I divide by 3. And so then B equals 17. So Betty has $17. Okay? To find Ann, you're going to plug Betty in. So you're going to get A plus 17 equals 60. Subtract 17. And so Ann has $43. And you're going to make sure you answer the question and say Betty has $17, Ann has $43. Okay, I'm just checking the time. Doing pretty good. All right, let's move on. Moving on. Sometimes, actually, and even the SAT likes this, they love number problems. I call them number problems. And we're going to get into harder ones, but a basic number problem means that you're dealing with two numbers. When we say that, if they're the same, I'm going to say these numbers are the same. Okay? Otherwise, let's assume that they're different numbers, okay? So the sum of two numbers is 115. The difference is 21. Find the numbers, okay? Well, let's let x equal one of the numbers. And always making our let statements. And we're going to let y equal the other number. So when writing our equation, we use what we're told. We're told that the sum of these two numbers is 115. And the difference, which means subtraction, is 21. All right, looking at this, right off the bat, I see all those coefficients of 1, but why is substitution not the best method here? I hope you're seeing right off the bat that the y's have the same number in front of them and their opposite signs. So therefore, elimination would be beautiful here. Just add the equations together. So we get x plus x, which is 2x. 115 and 21 gives me 136, and I'm going to divide by 2 on both of those. So we're going to get x equals, what is that, 68. Okay? And to find the other number, I want you to plug 68 in and solve for y. So I'm going to let you do that, and we'll check it tomorrow in class. All right, a couple other examples I do want to get to are linear models. Okay? So linear model. So let's just talk about our linear model with an average rate of change. An average rate of change is just our slope. Remember, linear model. A linear model, when we write these equations, most of the time they will be in y equals mx plus b. So that means we're looking for a starting place and an ending place, okay? So we want to be really, really careful here. We want to remember that the average, if you see the word average rate of change or something changing as a constant, at a constant rate, that it means the slope. All right, but we have to figure out what our two unknowns are. Notice I didn't give you any let statements here. A plant nursery is growing a tree that is 3 feet tall and it grows at an average rate, so that's keen in my head, of 1 foot per year. Another tree at the nursery is 4 feet tall and grows at an average rate of 1/2 foot per year. After how many years will the tree be the same height? So the question, just like when we did earlier, the question tells me my variables. After how many years? So we're going to let x equal time. Okay? Will they be the same height? So we're going to let y equal the height of the tree. Remember, time is always going to be your x. If you're not sure, ask yourself what depends on what, because y always depends on x. All right, then we have to write our equation. Okay, so let's look at the first tree. A plant nursery is growing a tree. It's 3 feet tall. So that's my starting value. That's starting value. It is 3 feet tall. Remember, our starting value is always like your y-intercept. So I know that right now I've got a +3. And it grows an average rate of 1 foot per year. So that average rate tells me that 1 is my slope. So 1x. And y equals mx plus b. So my height is going to be 1 times the number of years plus 3. All right, my other equation. I've got it that it's 4 feet tall. So my y-intercept is 4. My average rate is going up 1/2 per year. So 1/2 x. And that will tell me the height. Now this one's slightly different. You might not recognize that this is a great place to use substitution, and the question's actually telling me that. It says, after how many years will they be the same height? So it's basically saying, when are the y's going to be equal? So what you do is you take this and you plug it into y, or you set the equations equal to each other. So we're going to get 1x plus 3 equals 1/2 x plus 4. All right, let me move that up a little bit. Okay, so I'm going to give you a second to think about that. You're setting the equations equal to each other. Okay? All right, so now Coach Fred doesn't like to deal with fractions, so she's going to clear the fractions. It's just me. Don't have to. So I'm going to get 2x plus 6 equals x plus 8. I'm going to remember when I clear the fractions, I multiply everything by the LCD. I'm going to subtract x, and I'm going to subtract 6 to the other side, and I'll get x equals 2. Okay, so after how many years will they be the same height? 2 years. Okay. Coming together, remember, 2 variables, 2 equations, 2 variables, 2 equations. All right, last one I want to go over today, break even. Love break even. This is a business application, and I really think that this is that real life stuff that you guys always ask me about, okay? For a business, break even means where the income equals the expenses. So let's just say that Coach Fred, or actually you guys were going to have a bake sale, and Lauren or John or Mike or Matthew, you guys spent $20 to bake things, okay? You'd have to make that $20 back to break even. So you don't actually start making money until you have sold some of your baked goods. That's the break even point. So it's where our income equals our expenses. All right, so this is a break even type question. A fashion designer makes and sells hats, okay? The material for each hat costs $5.50. The hat sells for $12.50. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Okay, break evens are actually usually pretty easy. The question's going to tell me what I have to sell. So we're going to let X equal the number of hats we sell. Okay, but here guys, the Y is really going to relate to what we're making, okay? It's the dollars. It's the dollars, the number of dollars of income or expenses. That's the only tricky part. Because one question is going to relate to your income, one is going to relate to your expenses. Let me say that again. One equation is going to relate to your income, one is going to relate to your expenses. So let's look at our first one, our income. All right, well we've already said that we make $12.50 per hat. So that would be y equals 12.5 times x. That equation relates to the income I'm going to make. Depending on what I make x, I'm going to multiply that number by 1250, and that's going to be my income. The other one's going to relate to our expense. So our expenses, it costs $5.50 to make the hat, okay? Costs $5.50 to make the hat, and I spent $1,400 on advertising, so that's not changing. Remember when we wrote those average rate of change questions, that the thing that doesn't change, or the starting value, is your y-intercept. So plus 1,400 and then 550 times x. So the amount I have to pay to make the hat times the number of hats plus that $1,400 that I have. All right. So now it's very similar to the last question. It's asking, where are we going to break even? So where is the income going to equal the expenses? So it's basically substituting this in for y into the other equation, or thinking about it as setting the equations equal to each other. So 12.50x equals 550x plus 1,400. Okay? And so I'm going to go through the motions here. I'm going to subtract 550x